Okay. Isosceles triangles. So an isosceles triangle has at least two congruent sides. So just write down two congruent sides. It has exactly two congruent sides. This is how you name the parts. So we're going to look at just the vocabulary of it all. Sometimes they'll show you a picture of an isosceles triangle. Sometimes they'll just describe it. So it's important that you know the vocabulary as well. Legs. The legs are the two congruent sides of the isosceles triangle. They're two congruent sides. Whoa, it's blurry. And then the vertex angle is the angle that is up here. It's different from the base angles. The highlight so it matches. Here's the vertex angle. And then the base angles are these angles right here. Remember, the base angles are equal in measure. And then as far as the base, it's just the segment at the bottom. Okay, so here's the theorems, and I already kind of explained these theorems. If you have a triangle with two congruent sides like this, then your base angles are going to be equal. And then
Can I have your attention, please? Can I have your attention, please?
pause. Okay, so the converse of that is if you have two congruent base angles, then these two sides are the same. The legs are the same length. Okay, now next, name the congruent parts of each triangle. So here we're shown an isosceles triangle. It has two side lengths the same, so therefore this angle would be congruent to this one. And then for B, it shows you the two congruent angles, so therefore this side would be equal to this side. Okay, the next example kind of takes it up one notch. There's a little bit more going on here. So we just follow the directions. I'm using pencil so that I can erase what I'm pointing out because it'll ask something a little bit different each time. So it says AE is congruent to DE, so AE is right here, and DE is right here. So the base angles for those two sides would be right here and right here. So I can say that angle A is equal to angle D. Okay, the next situation, I'm going to look at what it says. It says that AB, so I just identified that segment, AB is right here, is equal to EB. So now it's just talking about this little triangle right here. So then the base angles that would be the same are right here and right here. So angle A, and we'll just call it angle E. Really, we should be more specific with angle E because angle E could be a lot of angles here, but we'll just keep it simple. Okay, the next one. It says that angle D, so I identify angle D, is congruent to CED. So when you identify that angle, just connect the dots, CED, and it's talking about this angle right here. So then this side would be equal to this one. So EC would be congruent to CD. Next, EBC, so again, just connect the dots, EBC, this angle right here, and ECB, so this angle, then this side would be equal to this one. So we could say that BE is congruent to CE. Now we're going to bring in a little bit of math. A shows us the two congruent sides, and it wants to know the other unknown angles. Well, opposite the congruent sides, these angles are equal. This is 50 degrees, so this has to be 50 degrees. And then all the angles of a triangle add to 180. So we can just take 180, subtract these two numbers, and get whatever's left over. So I'm going to subtract 50, and I believe it comes out to 80 degrees left over. And then B, it shows the angles are the same here, so therefore these sides are the same length. It shows 5 centimeters, so this must be 5 centimeters. They took it easy on us there. And then for C, C is similar to A. If this is 46, then this has to be 46 degrees. And then for the third angle, just 180 minus 46 equals whatever's left over. It's 88. And of course, always make sure your numbers are logical. So D is where it gets a little bit harder, but if you know what you're doing, it's really not that hard. We are given the vertex angle, and then we know that these two angles are the same measure. So what we have to do is subtract 40 from 180. So 140 degrees, but that's for both of those angles. Since they're the same measure, we can just do 140 divided by 2 to get 70 degrees each. Some of you may have already practiced that on Khan Academy. If you haven't practiced it on Khan Academy, that's on Khan Academy. And then E, this one, if this is 63, then this is 63. And then to find this one out, I can just do 180 minus 63 equals 54. Okay, and F. Here it shows these two base angles the same. That means that these two side lengths are the same, so we just set these equal. Okay, so one last page, flip it over to the other side. Now this page is about equilateral triangles, and equilateral triangle has all congruent sides. So as you know, triangles have 3 sides, so it would be 3 congruent sides. And so like I showed you on the board, if all your side lengths are the same, then all your angles are going to be the same. Or if all your angles are going to be the same, then all the side lengths will be the same. So it says, find the measure of angle P, Q, and R. Okay, well, since all the side lengths are the same, all the angles are going to be the same measure. And a triangle, the angles add up to 180. So we can just take 180, divide by 3, and get 60 degrees for each angle. So literally every equilateral triangle will have 60-degree angles. And then for this one, it says find the length of ST. Well, it says this side length is 5. It's an equilateral triangle because all the angles are the same. So then ST must be 5 as well. Why is it blurry again? Okay, and C, it says find value of xy. Well, again, since it's an equilateral triangle, all your angles are the same measure. For an equilateral triangle, it would be 180 divided by 3 equals 60 degrees for each angle. 60, 60, and 60. It wants to know the value of x and y though, so we just have to set this equal to each expression and solve. So 60 equals y minus 10, and here 60 equals x plus 5. And then x equals 55. Okay, and then we have some word problems on the next page. Okay, so here's what I was saying where it might not show you a picture. It says the measure of each of the congruent angles on an isosceles triangle. So I'm drawing an isosceles triangle so I can make myself a picture. And so when they're talking about the congruent angles, they're talking about my base angles. And it's saying that those congruent angles is 6 less than the measure of the vertex angle. So each one of these angles here, x minus 6, x minus 6, and then the vertex angle will just be 6. So it said the congruent angles are 6 less than the vertex angle, so that's why I wrote it like that. Now it's asking for the measure of each angle. I'm going to first figure out what x is, and these three angles should add to 180. So I can just say, okay, x plus x minus 6 plus x minus 6 equals 180. Okay, what now? Now I need to combine like terms to solve this. So I'm going to combine the three x's to get 3x. Negative 6 plus negative 6 is negative 12. And then just continue solving. So I get x equals 64 degrees, so that is my vertex angle. And then for these, 64 minus 6 would be 58. So this must be 58 degrees, and this one's 58 degrees as well. And then B right here. This one's same kind of problem. The measure of the vertex angle of an isosceles triangle. So drawing my isosceles triangle. The vertex angle is 15 more than the measure of the base angle. So my base angles are right here. They're going to be the same measure. And then my vertex angle is 15 more, x plus 15. Find the degree measure of each angle. So same thing, add these all up, put them equal to 180. X plus x plus x plus 15 equals 180. Combine your like terms to get 3x. Degrees. That's that. So pretty straightforward. As far as the homework, I do want to show you a couple problems just so you don't get stuck. This really builds, I don't know if you saw this in like 8th grade. This kind of starts at like an 8th grade level and starts to build, but for high school level, it is kind of like one step higher than this, and I'll show you what that means on the homework so you don't get stuck. So